So today we are solving difficulty problem level 1600. So this is the first problem. I'm going to solve the first these four problems. So this is the first problem. So Bitland is a beautiful land known because of its beautiful trees. Misa has found a binary tree with n vertices number from 1 to n. A binary tree is acyclic connected by diagonal graph containing n vertices and n minus 1 edges. Each vertex has a degree at most 3, whereas the root with the number 1. So it is given that the root at number 1 node, so it is at degree 2. Unfortunately, the root got infected. The following process happen n time. Misha either chooses a non-infected vertex and delete it, all the edges which have an edges in this vertex, or just does nothing. Then the infected is spread to every vertex that is connected by an edge to an already infected vertex, and it remain infected. Okay, as the Misha don't have much time to think, so please tell him what is the maximum number of vertex he can save from the infection. Okay, so what is given is that in this problem, so we are given a binary tree. Okay, in this binary tree we need to find how many uh, node we can save, so we can do some type of deletion. Okay. So deletion operation can be performed. So by looking in this problem, so what I'm thinking is that the first thought is come into mind for this problem is the greedy solution. Okay. So we are just going to go with the flow and try to evolve our solution. Okay, so it will be good. Let's say if I'm at this point and this is infected, this is infected, so I need to delete one of both of the two parents of two childs. From these two nodes I need to delete one of the node. Okay, so I need to save the maximum number of nodes. So I can see that there is only this node having two child only. If I delete this, I can only save two child. If I'm gonna delete this, I'm gonna save four child, four nodes. So you can say. So the best point to save the maximum number for, I need to delete this. So I need to delete this, or these are saved. Okay. This type of thing can be done at every position, but we gonna stuck with this solution if we have a node that have two children and both having the same number of child. Let's say it having three child, and or it having total number of node in this subtree is three, and same thing applies here. So we are just gonna, we can't come up with any solution. Like, now what we gonna do with the greedy approach? Okay, so we are kind of a stuck in the greedy approach. If both of these are having the same child, if the childs are not same for the vertices, it is good to have the child which having the maximum number of node. Okay, this will gonna save the number of uh, more number of nodes. But if the both having the same number of childs, then we're gonna stick with this greedy approach. So what we gonna do? So what we need at this point, if both of them are having the same number of child, or same number of you can say nodes in its subtree, so it will be good. We need to save the maximum number of node. So by any technique or by any algorithm, we can calculate. If we delete, let's say, name this child c1 and c2. Okay, if we delete c1, then how many node we can save? Okay, and if we delete c2, then how many node we can save? That what we want to calculate. If we can calculate, mm, somehow, by any approach, by any algorithm, these the answer of these two problems, of these two sub problems, then we say we're gonna delete that one, that will save the maximum number of nodes. That's what we want. Okay, so let's if we delete c1, if we delete c1, then all child of c1 are safe, then children of c1 are safe. Then how many node we can save? Then all the children are saved, plus then it is infected to c2. Then here we have to collect how many children we can save if c2 is infected, something like that. Then we have to do something recursion process. Okay, if we delete c2, then all the children of c2 are saved, plus what how many node we can save if c1 is, so if we delete c2, then c1 is infected. So we have, so now c1 is infected, so we need to calculate how many child can be saved if c1 is infected. So you can see that this is type of overlapping problems of a dp. Okay, so this evolves to our solution towards, so this indicate this point towards our dp. For this type of so what will be the equation of dp? So let's say this is parent, this is child c1, this is child c2, it having children c1, it's having children c2. So how many, if p is infected, so how many we can save? We can save max of, if max of both of these two. If c1 is infected, if c2 is infected. If c1 is infected, then, or if we delete c1, then all child of c1 is safe, plus how many we can save if c2 is infected. Similarly, if c2 is deleted, then all children of c2 is safe, and how many I can save if c1 got infected. So how many I can save, that's it. So I'm gonna take maximum of this. So in a line, it is equal to max of children of a node plus dp of children 2 and comma ch2 children of second plus dp of c1, that I want. Okay, so this is our solution. So this is a kind of a dp solution. So if you I hope everyone understand this solution. So if you don't, if you understand this problem, so code by yourself. Oh, moving towards the code, we are given a n. Oh my god. Okay, n and k. uh, I'm thinking about case, so there is no case. Okay, my bad. Then n minus, so we need a graph. Let's say a vector of type int and g. So g dot resize n plus 1, and for int I is equal to 1, I less than equal to n, I plus plus, and g of I is good. We need to clear it. Now for int there will be n minus 1 node. I'm gonna take all the nodes. Okay. Then g of a dot push back b and g of b dot push back a. So I already defined pb as a pushback here, you can see. Now I to run a dfs from the root, and it is already given is that root is 1. Void dfs int p int. So there are 2 or 3 ways we can do, run a dfs, a simple dfs, using a p parent pointer, or using a you can say boolean array or vector. Okay, how can we do that? So if we gonna do with, let me explain what I'm doing in bfs dfs. So when I'm at this position, so I need to see if I'm using a vector. So generally we use a vector that is of type visited. if it is visited, because when I'm running DFS at this point, so it will give me all the connected edges. So this one, this one, this one, but it is already visited, so we don't need to visit it again and visit both of these two. So we can already, we all also know that this is because this is a parent of this one. So we only need to store the parent. So if we say it is equal to parent, it one of its child connected element node is parent, so we not don't visit to that one. Okay, so we can do by taking the parent node, or by taking the you can say visit variable, visit array. So for auto it, our graph, I'm checking all the connected component of v, then dfs it parent of it v. That's it. Now I need a vector dp. So it is okay, I'm defining as a global element dp. I'm going to resize dp as dp dot resize n plus 1 and putting dp of I is equal to 0. Okay, here we go. So I know that dp of v is equal to max of dp of, I need all the children's. First of all, to take the children, I need a vector of, let's say it is child its children. Okay, so children will be pushed back it. So if it is, I'm going to infect it 1 or dp of 0, dp of 1, oh sorry, it is children 1 and children 2. Here we go. So what I need is how many child. So I need a another vector that will gonna give me how many children this variable have, like this children, this node have. So it node have how many nodes in the its subtree. So I need to modify the dfs, so it will gonna give me total children, total children. So total children will be, let's say it having, so this is a classic, you can say, to calculate the total number of uh, nodes in one of the subtree. Then this is a classic one, classic algorithm, you can say, or classic problem. Return total child plus 1. Okay, that's it. So now dfs of it comma v will gonna, now the this will be children total child of its children. So okay, so this will gonna return how many total nodes in the subtree of it, of this parent of this node. I need that one also. I'm gonna push back its children, its child, and child will be is equal dot push back its child. No, so it will be become a little bit fuzzy. So I'm just taking two variable, a ch and child, two arrays. So ch is going to store what are the child of, let's say, for if you visiting this node, so it having two child, this is let's say 2 node and this is 5, so it will going to store 2 and 5. Similarly, child is store how many root in its subtree. So for this it will having one, only one, that is 2, and for this it is having 3. Okay, so we have, I have two vectors, child and ch and child ch store the what are the child of this parent p, and child is how many number of vertex uh, in the respective child, that is 2 and 5, that I want to store. So it will be, I'm gonna delete 1 if ch node means first child is infected, then I'm gonna delete 2. That will be child of 1 minus 1, because child of 1 give me like child of 1 is give me the total number of node in this one. Okay, in this subtree. So if I need to delete one, so it is already given in the problem. So if we are going to delete a node, if we're going to delete the node, then it is not counted at it is a safe. Okay. So we need only how many are safe, that are connected, that node are deleted, that we want. So it will be child minus 1. Similarly, if we delete second first child, so if we delete first child, then the children of first child will be saved, and we gonna see how many children we can save if first child is deleted, second child is deleted. Okay, yeah, cool. So at the end we need cout dp of 1. That's it. Okay, let me run on the test cases. It is giving me segment fault. Oh, there are test cases. Still segment fault. Uh, n taking n and n plus 1. Okay, then taking all the roots a and b. That is fine. Then dp. Mm, dp of v is equal to, okay, yeah, I got the problem. Let's say if it is, if number of child is equal to 2, that now it is possible. Okay, now if all having the 2 child, then we gonna apply this. If if a node is there and this is having only one child, then okay, like for this node this is only having one child, so I'm going to delete this. So total save will be the total number of children it have. If else if child dot size is equal to 1, then how many we can save is equal to total children minus 1, that is child of 0 minus 1. Yeah. Oh, uh, dp of v, I think so it should work. As if size is equal to 1. Okay. See a child, it gonna push back, it gonna push back its children and all the stuffs. Total children will be, it will gonna, what is the total children? It is not giving answer, so it is a problem in DFS or something. Yeah, so there is a problem in DFS. So where the problem is this problem in this position or somewhere else? Somewhere else. Okay. DFS of it comma v, this is perfectly fine. Oh yeah, I got the problem. If it is equal to parent, then I need to continue, otherwise it will be running a infinite loop. Yeah. Okay, hope it is giving me, yeah, it is giving me answer. Yeah, it is accepted. So this is the second problem. So Marcia comes to pick mushrooms in the encouraged forest. So enchanted forest can be represented by n points on the x-axis, numbered from 1 to through n. Before Marcia started, her friend Patchouli used magic to detect the initial number of mushrooms on each point. represented by a1 to an. Marcia can start out any number of points in the forest on mint 0. Each mint the following happens in order. C moves from point x to y, and that is neighbor of x. Okay, C gonna collect all the mushroom on point y. A new mushroom appear on each point in the forest. Note that C can't collect mushroom on minute 0 after k minutes. Okay, so what are the ranges of n and k? N will be 2 power 5 and k is, so we are given a ranges of n and k. So you can see that n is 10 to the power 5 and k is 10 to the power 9. So there are two possibilities can be there. So first one is, if n is small, k is smaller than n, and if it is k is greater than n. So in this problem, I don't know like how C gonna pick up the, let's say I'm just solving this sub problem. So all the point are here. So I have, this is 1 to n point. Okay, where mushroom is going to grow. I don't know how C will gonna choose the point. So C will gonna choose something like that. C will gonna choose all the C will gonna choose a point where in a straight line. C is gonna pick up, C is moving in a straight line, or maybe um, C maybe gonna take this point also. C gonna got a turn. So we need to find which is optimal. Okay, so it will give me the maximum number of mushrooms. That's it. So in this, from both of these two paths, I can say that if I'm using this path, so total number of mushrooms is equal to, you can say, from all the summation from this point to this point of A. Because I'm moving from this point to this point, I'm going to collect all the A's, all AI's. And in this point, similarly, I'm going to collect all the AI that is are already grown, that is are already present on the points. And I'm 100% sure that this AI is greater than this one, because this is having the greater area. So, so if C chooses a straight line path, then C will gonna cover many point, much more point than if C take a turn. And okay, so by intuition we can easily say that this is always a minimal, which give me a optimal solution or best solution if we choose in the all the point in a straight line. That's it. So this is can be easily eliminated, this path can be easily eliminated. So if you are getting to stuck in the problem that is having different solutions, so try to eliminate first of all, figure out how many different solutions can be possible, and try to eliminate all others. Okay, now I need to how many, so what will be the solution. So first of all, I need a state path that is okay. So summation will be ai to an from of size k, because I can collect from k minutes, that is, and I can move k into k points. Okay, that is summation plus how many no so you can say that when I'm at 0, at I'm going to at 1 minute. So after that one is uh, mushroom will be grown up. When I'm at the 2 second minute and I'm at the second point, so I'm gonna collect all the that is AI mushroom plus one more. Okay, because up to this point one more mushroom is grown. Okay, so at this point, then at next point I'm gonna collect two mushrooms, at another point I'm gonna collect three mushrooms. So regardless of the AIs, I'm gonna collect 1 2 3 up to k minus one more mushrooms in k minute or in k different points. So this will give me k minus 1 into k minus 1 plus 1 by 2. Okay, so it will be equal to n into n minus 1 by 2. Okay, n into n plus 1 by 2, sorry. You can check it out by putting value 2 or 3 or whatever it is. So it will be, so this will be the summation of the of of uh, k summation of k points in a vector of our subarray, or you can say the summation of a subarray of length k, and this will be k into k minus 1 by 2. So you can see that this is type of a constant, this is a constant, and this can be a variable depend on ai, which subarray I choose. So this is a type of a typical problem in which we are just given an array and we choose an array of size k with the maximum value, with the maximum value of the subarray. Okay, so this is a problem of a prefix sum, a simple problem of prefix sum. So this part is solved. So answer will be the prefix sum of the maximum sum of a subarray of length k and k into k minus by 2. In the second problem, if k is uh, greater than n, so the possible paths are, let's say these are all the points from 1 to n. So the possible paths are, let's say it start from any point and stop at between of the point, at a between, at mid of between any point, or he may stop at the one of the endpoint. Okay, these two paths are possible, so I need to find out which will gonna give me the best solution and optimal solution, or you can say maximum number of mushrooms. So for this point I need to calculate how many mushroom. Okay, let's say for the k minutes. So one, the thing that is fixed is I'm gonna collect all the mushroom that is already present on the path, because I'm gonna visit all the nodes. That is completely possible, because this node, if I'm going the kind of doing this node, this I'm just type of moving from to and from motion from between some path, then it will not give me a optimal solution. That is absolutely clear. So we don't have to need about this problem of this path. Okay, so one of the path is so I'm 100% sure that I'm gonna cover all the points, and I'm gonna take all the mushrooms that are already present in the both cases. That not a problem. And after that, in the k minute, all point will be have and will be, so total number of mushrooms grown in k minutes at n point will be k into n. So how many after this point? Okay, I'm just, maybe many more rounds can be there. Okay. So how many mushroom is left? So total mushroom that I have collected, that is okay, and total mushroom grown in k minutes, that is equal to k into n, and let's say the remaining will be that much. So the answer will be total grown mushroom minus the remaining mushroom in the both path. That what I want to know. Okay, so let me calculate how many remaining in this path and how many remaining in this path, that I want to calculate. So first of all, let's go with this point. uh, so when I reach to this point, and I'm gonna collect all the mushroom from here, this point to this point. So at the end, this will gonna um, one mushroom gonna left here, then two mushroom gonna left here, then three mushroom gonna left here, then n mushroom gonna left here. So why you are thinking like that? I'm just reached at this point, I'm just collect all these mushroom at this end point, so must be zero mushroom will be there left. Okay, but in the problem it is stated that first I collect all the mushrooms, then a new mushroom is generated. Okay, so when I'm reached this point, I collect all the mushroom, then total number of mushroom left is zero. After this operation, all the mushroom will be generated at each point. Okay, so first, so one mushroom will be there, this point, this point, this point. Okay, so total number of mushroom left is n into n plus 1 by 2. Okay, let's say I just run take our take a turn and I just got up to z distance, up to z point. So how many mushroom is gonna left? Similarly, this distance will be n minus z. So similarly happen, say here will be 1 2 up to z is there, so z into z plus 1 by 2 mushroom left in this way, in this section. So in this section, first of all, similarly, when I reached, let's say I'm just starting from here and reach to this point, up to this point, uh, 1 to something like n minus z mushroom will be there. So that will be n minus z into n minus z plus 1 by 2 mushrooms are there. Plus some more mushroom will be grown in this point. So there are total n minus z points, and and how many time I gonna wait? So this will be z and z, so 2z. So at 2z minutes total, because at each second and one mushroom will be grown at each all the points. Okay, so there are 2z, I'm gonna go from here to here and coming back, so there will be 2z minutes. So in 2z minutes, that much of mushrooms are grown. So this is the total number of mushroom that is left. So this is a simple math equation. You can solve this. Z square by 2 plus z by 2 something n square by 2, and it is minus z square, so plus z square by 2, and the thing n z square to z minus 2 n z by 2. Okay, plus n by 2 minus z by 2, that's it. And here is 2 n z and minus 2 z square. So minus z square plus z by 2 is cancel out, and z square by 2 z square by 2 is z square, 1 z square and minus 2 z square, so it will be minus z square. Okay, it is n square by 2, this is minus 2 nz, or you can say 2 is got cancelled, so nz, this is 1 nz, this is 2 nz, and the remaining will be 1 nz. The remaining one is plus n by 2. So you can see that if I'm going to take this 2 as same place, that will be n into n plus 1 by 2 plus, and I'm taking z common in this point, so will be n minus z. Okay, so remaining mushroom will be this much, n into n plus 1 by 2 plus n z into z minus 2, z into n minus z, and in this case the mushroom left is n into n plus 1 by 2. So I need to, so it is already proven that n is greater than z, 100% greater than z. Okay, so this is always a positive integer. So in this case more mushroom is left, and in this case less mushroom is left. So the mushroom left, so the optimal case, I need to finish at a end point, that will be a optimal case. And how many mushroom will be gonna left? That much of mushroom is gonna left. So our answer will be how many mushroom are going to be collect, that is summation of all ai's plus how many mushroom is grown minus the left, the remaining one, let's say it is r. So that much, that is r, that's it. So this is a kind of a more, you can say, is a mathematical problem. So I think that is a mathematical equation, so you need to you can understand it very well. So let's code it, let's do the code. If you understand by your the problem concept, so you can do the code by yourself. Okay, otherwise follow me. Okay, so what we are given, we are given n and k, int n comma k c comma k, and we are given a kind of a fact, let's say long because it is the power of 10 to the power 9. Okay, and for I to n, I'm taking c a of I, and I'm making a prefix sum. Okay, so if I is equal to 0, I'm making it continue, a of I plus. So I'm kind of making it a prefix summary, a. Okay. After that, there are two possible conditions if k is greater than n or else k is smaller than n. If it is greater than, the total answer will be total a of what is a of n minus 1. It is total plus n in k into n by 2. Okay. Okay. So it will be long answer n minus 1 and answer that how many total is grown n into k total mushroom is grown, and how many b gonna left will be n into n plus 1 by 2. That's it. So this is our answer. Okay. So if it is smaller than n, so I need to find the maximum of I need to find the maximum of a subarray that is of length k. Okay. So 4 int I is equal to 0, I less than n, I plus plus max is equal to max of maximum. Okay, and it is a of I need a variable temp, a of I plus k minus 1, and if and temp minus a of I minus 1. So from ai minus 1 to ai plus k minus 1, it will be having k elements, so sum of k elements. So it is I minus 1 should be equal to greater than equal to 0, and it should be less than equal to k. If I plus k minus 1 is greater than equal to n, I'm gonna break it, so it will gonna exceed my array limit. So that will be the max of maximum comma 10. So what will be the answer? Answer will be the maximum of the subarray of length k plus n into n plus 1 by k into k minus 1 by 2. That's it. See out answer. 12 985. Okay. Oh, actually I already did this problem. Okay. Give me something TLE or something. Oh, it is running. Yeah. Oh, it is separate. So this is the third problem of the day. So what we are given? We are given a string s of characters 0 and 1. You have to remove several characters from the beginning of the string and several from the end of the string. String may become empty after the all the removals. So the cost of removal is the maximum of the following two values: the number of the 0 character in the string and the number of 1 removed from the string. Okay, I need to, what is the minimum cost you can achieve? Okay. Okay, so what we are given? We are given a kind of a string of 0 and 1. Let's say I am giving this string, so I need to remove something such that the answer is optimal. What is the answer? Answer is, let's say after removal the string left is something like that, and this string is left. So what I need to, the cost of removal you can achieve. So the cost of removal will be the maximum of the two values, that is the how many zeros are present that in the string is 2, and how many one are removed, 1 2 3 4, 1 2 3 4 4, that the cost will be 4. Okay, so you can see that I need to need optimal solution. So what I can do, uh, mm, so we need some observation. So you can observe that uh, the string is constant only 0 and 1, and I need how many. So we can do this problem by the using of binary search. Yeah, if we go with binary search, okay, because by binary search, because this is a type of a or a monotonic function. Why? Because if uh, for this point, let's say the answer is 5, if it is not possible for, if it is possible for 5, if the answer is 5, okay, so this is not possible. For this will be showing the minimum, the answer is minimum, and for this showing the answer is maximum. Okay, if we are just checking for this point, you can easily say that this answer is possible and this is the maximum answer. So we need to come to down, and if we checking for this position, so you will gonna see that this is the minimum answer. We can't do for this, let's say 3 for the 3 cost, so we need to increase the answer, and that what we do in binary search. Okay, so in binary search we gonna fix a point, let's say c cost, and if we gonna check that c can be possible or not, so what I need to do is uh, so total number of zeros, let's say this is our example, I need a c zeros. So the total cost will be, I'm taking all the element from c zeros, so from here to here. Okay, so it will gonna a subarray which gonna only c number of zeros, so it will gonna contain 1 2 3, let's say c is equal to 3, 3 number of zeros, and the, so for this array, so I'm saying that this array I'm gonna need this array, I'm gonna remove all the elements regard and saving this array. So what is the cost of this one? So the cost will be 3, and the removed element, that is 2. So I'm saying that answer is 3 is coming, so 3 can be possible, so answer 3 is possible. So I'm gonna chat for 2 and 5 and all of these things. Okay, that will be a binary search. So you can see that I'm taking an array, let's say I'm just for c is equal to 3, I'm taking this point to this point. Why I'm taking from this point to this point, all the subarrays. Okay, let me go from here to this point only. So first time what I'm saying is that I'm taking a c is equal to 3, that I, so I'm checking that 3's answer, the 3 is possible or not. Okay, so I need to remove the string such that the answer 3 is possible or not. So what I'm thinking is that I'm just taking that if 3 is possible, so the number of c's, that is the number of 0 in the string is 3. So I'm taking 1 2 and 3 zeros, and you can see that I'm also taking including these two all. Okay, what are, you can say that why are you including these two much more ones? I'm including these because, so the cost of the removal is number of uh, I need to minimum the cost, that my work is to minimum the cost. So the cost will be the number of zeros in the string. So you can see that it is not the number of one in the string, so it will depend on number of zeros. So I and number of ones that are removed. Okay. So I need to minimize the number of one that are removed. So how can I so I need to take only three zeros, and I need to minimum the number of ones that are removed. So I'm just taking 3 up to here. I got the 3 point, or you can say 3 number, and I need to take, and if I'm gonna take these 2 point as well, so it will gonna reduce the cost, that is the removal of 2 1. Okay, so it is always be optimal if we gonna take the string. So it will be a kind of a, so if we need to take in the middle of something like that, and the three zeros, so I'm taking the zeros, these three zeros, one, two, and three zeros. So I'm gonna take the string from here to here, all the one from here to here, so that the cost will be max minimum. So what I'm going to take, let's say the three zeros are from this point to this point. So I'm gonna take all the next zero, the previous zero is this one. So just one position greater than this zero from this point, and the next zero is this zero, that is the next zero, and a one previous position from the this next zero. So this string from this point to this point only having three zeros, that is the our midpoint, or we can say our from what point we are checking, and containing the maximum number of ones. So the number of one removal will be minimum. Okay, that's it. So we need kind of taking all three, like I'm taking three zeros, these three zeros, then these three zeros, and I'm checking if it is possible to get these three zeros, and what else, the number of one removal is, the cost will be minimum than this three, then answer is true for this point. If it is false, accordingly we do kind of a binary search. So we are just doing if it is possible for this point or not in the binary search. So how can we do that? Okay, we come up with the solution. Okay, we are doing binary search and it is okay. So how we gonna do that? So the answer is something like that. So if I'm just storing a vector, that will be only give me the index of zeros. So it is 1 2 3 4 5 6 7 8 9 10 11. So string is kind of too big. I'm making 12 and 13. Okay, so I'm just storing the indices of zeros. It is 1, then 4, 7, 10. Okay, so I'm just checking for L is equal to, answer can be 0 and answer can be up to n, that is 13. So I'm checking for, let's say for 30, any middle point or any point. If it is 6 for the middle point, that is 6. I'm checking for 6 if it is possible or not. So I am having this array only. Okay, why I'm taking only zeros array? Because I know that, because I have first I observed that there are only two elements is possible. Okay, so first from 4 to 7, the total limit will be 4 minus 7 minus 4 plus 1, that is 4 elements are there. From 4 to 7, 4 elements are there, so number of zeros are 2. So I'm 100% sure that the remaining two elements are ones, because it is already given that the string is containing 0 and 1. So I'm just taking these elements only, so this will be easy for me. Okay, so let's check for the 6 is possible or not. So I'm 100% sure that the number of zeros is that much. The number of zeros is, that is 4, so 6 can be easily possible. Why it is so? If I'm taking the full length of the string, that is full length, so number of the cost will be the number of 0 removed, sorry 1 removed, and the number of 0 inside, that is present in the string. So maximum answer can be, so if I don't remove anything from the string, so the number of 0% in the string, that is 4. And so 6 can be easily possible. So 6 answer can be possible because answer is much may lesser than 6. So I need to go downward. That is 6 can be easily possible. So I need to go that is answer that is great less than 6. Okay. Okay. Then the 6 L, so R L become 6 from 0 to 6, or I can say if 6 is possible, I'm checking 5. That is 6 minus 1. I'm checking from 0 to 5 because 6 is for 6 it is possible. For 0 to 5 that is L, then mid will be become 5 by 2, that is 2. So I'm gonna checking for the 2 if it is possible to get the answer 2 or not. For 2 1, okay, I need to take uh, the subarray which having the two zeros. So I'm taking and maximum number of ones. So two zeros and maximum number of ones. So this array. So this subarray having two zeros, that is, so the cost will be how many zero inside, that is 2, and how many of the uh, one that is removed. Okay. So I'm saying that the total number of length is 13. So there are 13 0 and 1, and the number of zeros are 4. So I am 100% sure that there are 9 1 in the subarray, in this total array. And how many is inside the this my subarray? So total number of is inside, that is from I'm taking a subarray from 1 to 6, from 1 to 6. So between this there are two zeros, so remaining one will be 1, so remaining will be 4 ones. Okay. So how many one that is present outside the subarray, that is 5. So the cost will be maximum of 2 and 5, that is 5. So for this subarray answer 2 is not possible. I'm gonna check for another one. So I'm taking a subarray from uh, these two zeros. So I'm gonna include the maximum number of ones, that is from here to here. Okay. So for this point, for this subarray, the maximum number of one is, that is outside is 3, and maximum number of 0 that is inside is 2. So still answer is 3. So 2 is not possible. I'm gonna take another array. I'm taking this array, these two zeros. Okay. So I'm just taking include all the maximum one can I can. Okay. So the outside, the number of one that is outside of this subarray, that is 2, and number of 0, that is 2. So answer 2 is possible. If we are remaining this 2 subarray, if this subarray, then answer is 2. So I can 100% sure that if we remove something, that is if we remove this subarray or these element, so answer will be 2 can be achievable in this problem. So I'm gonna guess that answer 2 is possible. I'm gonna check for 2 minus 1, that is 1. So 1 0 1 by 2. Yeah, I'm gonna check him for 0. Similarly, these thing gonna happen. Okay, kind of a binary search. So I think so everyone gonna understand this problem is a little bit easy problem. So let's go for a code. What is I given you the string as only. Okay, and I'm creating a vector of indices of zeros of size can be anything. For int I is equal to 0, I less than n, I plus plus. If s of I is equal to 0, I'm gonna push back this index. Now I'm going for a binary search. L is equal to 0, R is equal to 0, and while and I'm put answer is equal to 0 if R is greater than equal to L. and I need to define n is equal to s dot size. S dot size. Okay. Int mid is equal to L plus R by 2. I'm gonna check if it is possible for, that is mid is 2, total number of element is n, and we have indices of 0. If it is possible, so answer will be mid, and I'm gonna take L is equal to L R minus 1, mid minus 1, else I'm gonna take L is equal to mid plus 1, and I'm gonna output the answer. So I need to uh, so we are just going for a OK function. So first of all, we are given a mid, size of zeros, then total number of int n, and vector of int, indices of zeros. So first of all, if mid is greater than int plus size of zeros, so I'm 100% sure that this is can be possible. Return true. Okay, now I need to say if it is possible or not. For int I is equal to 0 in less than an I plus plus. Okay, so how many number of ones in I need k? So I'm just checking for this point mid, and I'm gonna say int dot size. Okay, so one removed, total number of ones that are removed is equal to, so first of all, how many zeros I'm taking the j is equal to I plus mid zeros, that's it. Okay, if I'm at I position, I need to take one more, that is I plus mid minus 1, sorry, minus 1. Okay, so the length is, so the length will be from, first of all, if I plus mid minus 1 is greater than int dot size or is equal to its size, I'm gonna break it down. Okay, then I need to find how many one in this position. So the next 0 will be at this position, so the position of next 0 will be uh, mid of this one. So I need a, okay, so I'm gonna push back minus 1, so I need, okay, so in this array I'm gonna push back n plus 1 element here this side and minus 1 this side. Okay, this gonna give me an indication that uh, let's say if I'm just putting variable from here to this point, I'm taking sub array from this point to this point, and I'm also taking all the one that is next to this point minus 1 from this up to this point. And similarly, if I'm saying that minus 1 is also a 0, so the length will be uh, up to this point plus 1. Okay, so as a type of indication, I'm just taking 1 4 7, that is minus 1 and n plus 1 element in my array as a point of indication, nothing else. Okay, or if you don't want to take it, it is okay. If you think that it will give me a kind of complexity. Okay, so the next index will be I plus mid minus 1, and the current index is equal to I. So if I is equal to 0, I is equal to 0, that means, okay, so I is equal to 0, I is equal to 0, that means if this is kind of a subarray, 1 1 0 0 1 0 0, so the vector indexes will be holding 0 zeros. Okay, so this index something, this is 0 and 1. So 0 means that this is the first element, this is the first 0 at this point, whatever point it is. So I'm gonna, for the maximum number of ones, I'm taking all the subarray from 0. Okay, I'm taking subarray from 0 to something else. I'm gonna figure out what will be the something else to include the maximum number of one. If it is, this is the first 0, so I'm just gonna take out to the up to the first point. If I is equal to 0, so the current, so the previous index, so previous point of index, so previous point will be I is equal to 0 will be 0. Else if it is not 0, so previous point will be previous point. These point are of index, that is the I index of I minus 1 plus 1. That's it. I'm taking the first point, or it is will be good if I'm taking the, I'm just taking a first and last point of the subarray that I want to include with the number of zeros between them is mid. Okay, and it will be, next point will be plus 1 is equal to in dot size, then last will be n, that will be n. Oh, else it will be last is equal to that which index, I plus mid minus 1. So the total number of 1 will be, okay, okay. So this will maybe create a little bit confusion for you. So what it is, so I am having 0 0 0 or something zeros. Okay, so I need to like take, I'm taking two zeros here to here. So and I need to count, take the maximum number of 1. So maximum number of 1 will be, so the next 0 from is this point. So I'm 100% sure that the previous point of this is 1, or it is the same point. If it is this case, then previous is this same. Okay, so I need to subarray from this point to this point, so the number of 0 will be the 2, but the number of 1 will be same maximum that I want to take. Okay, that I want, that I did in this case. Okay, so I don't need this point. So this is a type of to understand you what I'm trying to do. So first of all, the total number of ones, total number of 1 is n minus index minus size. Okay, so index will be the number of zeros, so total number of 1 is that much. And so number of 1 in this subarray is equal to the length of subarray, that is first minus last, or it is n minus 1, because I'm taking from 0 to n minus 1. Okay, first minus last plus 1, sorry, last minus first plus 1. Okay, and so this is the total length of total number of element in the subarray, the taking the subarray from first to last, and number of zeros in this is mid. And if once, so the cost will be cost of the current subarray, int cost is equal to maximum of the number of zeros and number of ones, number of one removed. And if the cost is less than mid, So I'm 100% sure it will gonna return me 2. So this cost is possible as this cost is not possible. So 1311. It is kind of not giving me the one. Let's see what is going on here. Okay. For 1 3 and 1 it should be 0 0, but it is not going to give me 1. Why it is? Because maybe if I'm taking a remove from here, this point to this point. Okay, actually what is happening going on, I'm just taking, okay, so for this kind of array, okay, so 0 0 0 and 1 1 1. So this kind of array I am taking answer, let's say when while iterating, let's say answer 0 is possible or not. So I'm taking all the number of 1 from this to this point, between the point, okay, from this to this one, so it will give me, and here to here. I'm not trying to take all these ones, so I need to take that 0 is all also at position n and at position. So what I'm say is that, let's say these zeros are uh, so when answer 0 is possible, so when answer 0 is possible, if something like that, I'm just taking all the one inside a string and trying, and all the zeros are removed and no ones are removed. Okay, so if string is something like that, and after removal the string is something like that, only ones are there, only zeros are removed, so the cost is equal to 0. But in this case, if these all are ones, so I can't take, because my array is having the last position at this point. So if I'm saying that, after, let's say this is the n minus 1 index, after n point, okay, after this n, I'm 100% sure that, uh, so I can also assume that at n position there is also a 0. Okay, so because it will not gonna affect my answer, so I can take this array as well. So I need to push, first of all, in that push, so the first one is -1, and at the last I need to push in depth dot push back, push back, that is -1, and the number of zeros will be index of size -2, because I'm already pushing two more zeros. Still it is giving me, why it is giving me 0 answer? Okay, because the first index is always -1, so we need to remove that one. Oh, so this is giving me answer 3. It is giving me answer 3 because the answer is, if it is 0, if it is greater than equal to, then it will be, answer will be 0. Yeah, here we go. So it is type of a little bit complex in kind of making the arrays and taking the vector kind of thing. Okay, it little bit complex problem in time of type of coding, but the concept is really simple. So you don't think about the concept. What we need to do is, we only need to do maximize the number of one inside our string and taking the zeros. We need to only count the number of zeros in a string and the number of one that are removed, but the code is little bit complex for this one. Okay, so this is the fourth problem. So what is given that, uh, okay, so he has a permutation of p of length, and recall the permutation p of length is that is a sequence p1 to pn that all integers are distinct. C want to know how many different indices that tuples can be possible, a b c d, that is a b c d. So what is given is that if I am given a permutation, something like p1 p2 p3 up to pn. So how many it is possible, like how many tuples are possible such a b c d, such that a b c and d all are increasing subarray, increasing indices, and the values of pc is greater, and for b and d, b is greater. I need to find how many tuples are possible. Hmm? So you can see that n is always less than 5000. So I can do in n square. So n square is possible. So what I need to do is I'm in n square. I need to calculate this one, and this will I'm gonna find out how can I calculate using set, multiset, or any type of data structure. Okay. So let's say this is p1, this is p2, this is p3, p4, this is p5, and this is p6. When I'm just iterating over I, this I'm taking this I, and another point that is j. So at any point I'm reached to this point I. So what I need to check how many pcs are smaller. uh, so I'm just fixing pc at this I point, and for all less than I less than, that is for all the index that is are less than, I'm just fixing this index as b, and I'm taking how many index that are smaller than b, and value of, let's say I'm just taking this as j. So all the smaller, this is can be using by two for loops, and value of pb, pa and pb satisfy this inequality. So I can do that. So now what I need to do is that how the we have these elements and we have these elements. Okay. So these element are, sorry, this is c, sorry, this is c. Just I'm fixing I as a c. Okay, my bad. So I'm fixing a point that is c here. I'm fixing c, and all the a are less than index of c, and values is greater of c. So I can use a two for loop in this situation, and for finding a and c. Now I need to calculate a b that is between a and c, and d that is between, that is greater than actually c. Okay. So I can do this by using pre-computation, or using kind of pre-computation of arrays and something like that, but that will be a little bit more lengthy code. So in similar thing, how I can use something like bit tree, that is not so large, and code is also little bit small, and it will gonna give me answer. So what I need to do is between, so first of all I need to satisfy b of b should be greater than b of d. I need to satisfy this condition. So I'm gonna put all these element in my bit, and trying to find out between these element, like uh, which element is greater than how many elements in this set. Okay, in this set how many elements are satisfying this inequality. So you can see that this subset is not changing for a loop. Okay, like I'm fixing I here. Now j is changing, so j comes from, go from I minus 1 to 0, but this set is not changing. So I can take advantage of this one. So I'm just fixing all the point in the bit for this all this set of this point. I'm just taking that this is possible, this is present in my bit, and okay. And then let's say I'm coming at this position, so I'm gonna say how many elements are greater, are smaller than this point, my this point, okay, in this bit. So I'm gonna find out this is in, you can see, in log, and in log on time. You can do it using bit tree, okay. If you don't know about bit tree, so please read once about the what is bit tree in the hacker rank, or you can refer the cp algorithm, and here is a bit tree, uh, cp algo bit tree, or what we as bit, okay, pen victory, okay. So you can refer from here, we are just using these algorithms, okay. So let me write the code, then you will gonna understand. This is a little bit, you can say, not a hard problem, you cannot say it is a hard problem, it is a straightforward problem, okay. But a more complex algorithm is used, like here we are going to use a bit tree. So what is the length of the element will be 5000 only. So I'm gonna take, I'm just making a bit tree, or you can say not a bit tree. Bit is a full form of binary index tree, so I'm just making a bit of maximum size 5 into 10 to the power 3, okay. And vector of int bit of size maximum, long answer of int is also, for int I is equal to 0, I less than n, I plus, first of all I need a vector of typing a of n, and for I to n I'm just taking a of I, okay. And t test cases int n, okay. Here we go. For int I is equal to 0 to I less than n, and for j is equal to 0, j is equal to I minus 1, and j minus minus. So if it is possible that the condition will be a of j should, this condition should be must be follow, then I'm gonna increase my answer. So okay, okay. So there are two function in the bit, that will be update of a value in x at index x, I need to update value, okay. And so the algorithm for this is x should be less than maximum, and x plus is equal to x into minus x, and bit of at position x will be where, and I need to return the sum that is up to index x. It is similar to this only. Int result is equal to 0, bit of x, we gonna return the result. So this is a standard algorithm of a bit tree, okay. So answer will be how many, what is the total sums. So it will gonna give me what are, first of all I need to update, I need to update a bit tree, okay. For int j is equal to I plus 1 and j is less than n, j plus plus, I need to update the binary tree, that is the value of aj will be there. And first of all, for int I is equal to 0, I less than maximum I plus plus, or you can say k, I need to erase the array, the bit tree, bit of k is equal to 0. Okay, i'm gonna s- I'm gonna set the bit tree and gonna update that this value is present, this aj is value 1. So that what that means is aj is present, aj plus 1 is present, something like that. So these values are present, so value is 1, that means this value is present. Okay, so if it is less than, so now, so how many values, mm, will be some, current will, answer will be, so I'm gonna tell you what is current is. So what current is, current will be the sum of, mm, sum that are smaller than a of j, that are smaller than a of j, and I need maximum, so maximum will be total minus are smaller than this one, and total will be, total will be these total elements. Okay, so wait a minute, I'm going to tell you what I'm just doing, and I'm gonna update a of j, well, no, I'm not gonna update actually, I think that's okay. Yeah, that's okay. So what I'm doing is, first of all, I'm just taking a bit. In the bit there are two so I'm just taking give a kind of a high overview. Okay, so I'm giving a overview, so it will having a two function, one is update and what is sum. So it will gonna do a kind of a it work on a bits kind of thing. Okay, so update will be give, so what update is, update will I'm just saying update a of j, a of j means, like, let's say I'm having array 3 2 5 6 7 8 9, so up to I'm just having index I is here, that is index c is here, so I need update this all in my bit tree. So I'm saying that update 7 that is having value 1, update 8 having value 1, update 9 having value 1. Then I'm just coming to this point 5, I need to see how many elements. So the total number of elements are in the bit tree is equal to 3. That much I updated. Okay. Now I'm at index I. So first of all, I'm gonna see, and I am having a variable current. Okay. So I'm gonna tell you what current will gonna have. First of all, I'm gonna see, like, this is A or C. So value of a is greater than c, let this is possible, so I'm gonna answer will be plus current, but still current is 0, so nothing gonna happen. After that, you can see, after that, after taking this value, I'm gonna taking the sum into the current. So the value, the current index at 5, so I'm gonna making that how many element, the sum will be written how many element that are smaller than 5. So there are 0 element actually that are smaller than 5. So okay, uh, let make this variable something like this, 10 and 5, you can say 8. Okay, okay, otherwise these are smaller, this always give me 0 answer. So I'm just at 5 position, so it will give me how many elements that are smaller than 5, that so it will give me 0, all are greater than 5. So how many are greater than 5? So total element are 3 and smaller than 5 is 0. So 3 are greater than 5. So I am saying that 5 is satisfying this inequality, that P of B's must be, so I need to satisfy how many pair of points are satisfying this inequality. Okay, that are greater than P of B are greater than P of D. I need to find out. Okay, so how many are, okay, I'm doing something wrong or it is correct? Yeah, it is correct. So if P of B is 5 and in this bit tree, in this element that is 7, 8, 9, I need to find out how many elements that are smaller than 5. So the smaller than 5 is are 0. Okay. So I don't need this. It will gonna give me how many elements that are smaller than A of J. Okay. Okay. So I'm doing this thing. Okay. So when I'm at this point, first of all, I'm seeing that if it is first equation is push, okay, it is make me another array 8, 9, because that will be become a kind of compact and rushy thing. 9, 6, 7, 10, 11, 7, 6, 5 or 6 something. So at this point, this I'm fixing my C here, and in my bit I'm gonna update, and I'm having value 7, 10, and 6. So I'm at this point. So I'm seeking that if it is satisfying my first equation, the first equation is P of this is something, C should be greater. So it is not satisfying. I'm at this point 8. First of all, I'm just updating the current for 9. How many elements that are smaller than 9? So how many elements are smaller than 9? So it will going to return me 2 element. Similarly for this equation is not satisfied. So I'm just adding the current. How many elements that are smaller than this? This is 2. 8 from 8, that is 7 and 6. Okay. So current is will be storing all these points. Okay. How many this equation can be B comma D? How many elements or how many pair are satisfying this inequality? So the current is storing that much. And when I found that how many, if this equation is satisfied for pair 3 and 6, so how many elements that are between 3 and 6 satisfying the second inequality, that is current. Okay, this is storing current. That's it. So it is a kind of straightforward problem, but you need to know about a little bit. Okay, so what is happening going on here? Update A of I. Okay, I think so. I'm not using these function. These are not correct. So let me check this. So these are on hacker earth. In data structure and in the advanced, this is the sand victory. In the tutorial section, I am having where it is. The query will be x. So this is a function for the sum or query, whatever it is. X must be greater than equal greater than 0. Okay. So this is a problem, and x minus x. Okay. And what about update? So update will be x is less than equal to maximum, that is 100% fine, and it is equal to x plus. So yeah. Now it okay, I'm not outputting anything. So see out answer. So it will give you how many tuples can be possible. 3 to 28. 30. Okay, 3028. So you can see that it is not a kind of complex problem, but using bit is a, you have to know about a bit. Okay, so if you don't know about bit, so please read about it. Then this problem is very easy for you. It is giving me TLE or something. Okay, it is accepted. Yeah, 66. Okay, so thank you.